Now today we're gonna see how do we solve rational equations. Now the main idea here is that we're gonna try and write every single rational expression using the same denominator. So the first thing we want to see is if they have the same denominator. Once they have the same denominator, then we're gonna try and solve them. So that's the main idea here. We're gonna try and write every single rational expression with the same denominator, and then after that we're gonna try and solve them. So let's try some examples here. Now, looking at the first example here, let's try to solve the following. So we have two rational equations, r minus 5 divided by 5r, and 1 over 5r. But what do you notice here? They have the same denominator. So step 1 is done. Now, what happens when they have the same denominator? Or why do we want to write them using the same denominator? It's because once they have the same denominator, they will cancel out. And now, our problems before, r minus 4, which is the top of the left, equals 1. So once the denominators are the same, they will cancel out, and then you just worry about the numerators. And now here, it's a one-step equation. So you have that r is equal to 5. Okay, this is only true once they have the same denominator. So that's our strategy. We're gonna try and have them write the same denominator, and then we're just gonna have the numerators equal to each other. Now, why is that true? This is because you will cross multiply. So if you want to do it the long way, so this is the long way, 5r. So if you decide to do it the long way, then make some space here. Oops, I guess not. Now, why is it that they cancel out? They cancel out because when you cross multiply, so imagine here, you will cross multiply. So now, and you will cross multiply this too. So now you will have r minus 4 times 5r equals 1 times 5r. So if you cross multiply, you have this, and then here you can divide 5r to both sides. So this 5r we cancel with this 5r, 5r we cancel with this 5r, and then we'll have r minus 4 is equal to 1, which is exactly what we have here with the shortcut. So this is why the denominators will cancel out. It's because when you cross multiply, they will cancel out. This is just the explanation. This is not part of the problem. It's just an explanation as to why they cancel out. Okay, but we're just going to do the shortcut. They have the same denominator, we cancel. So let's look at the second example here. Again, notice denominator r squared minus 2r, denominator r squared minus 2r. They have the same denominator. So what happens here? They will cancel out. So now you have r plus 5 is equals to 1. And then you would just solve it individually. Minus 5 here, minus 5 here. So now you have that r is equals to minus 4. And that's pretty much all you have to do here. Now this is when we're solving. So there has to be an equal sign between the two rational expressions. So if there's an equal sign, then you can cancel those denominators. Pretty straightforward once you have the denominator equal to each other. But now, what happens when the denominators are not equal to each other? Well, your objective is still the same. Like you want them to have the same denominator. So we need to write them using the same denominator. So we can use the idea of an LCD, or the least common denominator. Now, what is the least common denominator? It's you're basically going to group all the expressions on the denominator. So I see that one of the expressions on the denominator is n minus 8, n plus 8, I'm sorry. So it's going to be part of your LCD. Now let's look at the other expression. That's n plus 1. So that's n plus 1. So you already grouped all the expressions on the denominator. So that is your LCD. So we're going to try and write every single denominator. It should be written as n plus 8 times n plus 1. So this is the lowest denominator that both have in common. So let's come back to our problem. You want this denominator to be written as n plus 8 times n plus 1. So what are we missing here? We're missing the n plus 1 from the LCD. So we're going to multiply n plus 1, top and bottom. Okay, so now That just takes care of the left side. So now let's look at the right side. On the right side, I have n plus 1. I want it to have the same as the LCD. So what do I need to multiply? I need to multiply by n plus 8. Because what you want to do is you want them to have the same denominator. So now they have this, then we can start doing our multiplication now. So let's perform our multiplication. You multiply two fractions, so you multiply top, top, bottom, bottom. So let's do our multiplication. N times n is equal to n squared. N times 5 is equals to 5n. 1 times n, that is equal to n. 1 times 5, that is equal to 5. This we're going to divide by the LCD, n plus 1. There's no need for you to multiply this, just leave it because you will know that they will cancel out. So this is our first fraction or first rational, and that is equal to, well, let me raise this equal sign because it might be confusing, equal to, now let's multiply the right side, 6n, and 6 times 8, that's 8 times 5, that's 40, that's 48. So 48, we have the LTD, n plus 1 times n plus 8. So notice that now they have the same denominator. So just like in our previous example, same denominator, they will cancel out. So now we just worry about the numerator here. So let's just rewrite it, n squared. You can combine this two, and 5n plus n, that's 6n plus 5 equals 6m plus 48. The denominators cancel out, so you just rewrite the top. I simplify this. So now we want to solve this. Notice that the 6n's will cancel out if you subtract 6n to both sides. Cancel out, cancel out. So now we have n squared plus 5 is equals to 48. You want to solve for n here. So the first thing I want to do is leave the n squared alone. So we got to subtract a 5 here. So subtract 5, 5. So now you have n squared is equal to 43. You want to leave n, so you need to get rid of this square second exponent. And from our previous videos, you gotta multiply by the opposite. The opposite of an exponent is a root. So if you want to cancel out the second exponent, you need to take the square root to both sides. This way, the square root will cancel out. And now you will have that n is equal to plus or minus square root of 43. 43 is not a perfect square, so we're going to leave our answer like this. So n has a value of square root of 43. The problem might seem long, but it's the same idea here. You need to write them have the same denominator. Once they have the same denominator, they will cancel out. We use the idea of an LCD here. And then you just worry about the numerator.